Hello, year 8. Today's lesson is pretty straightforward. Should be a little bit of revision for you, but there should be some new stuff too. To start off with, make sure you've got your periodic table open just in case you need it. And remember to rotate it via the view, rotate view, and clockwise. So let's get straight into it. We're going to the PowerPoint to start with. Okay. Pause the lesson, or pause the video I should say, and copy and complete those sentences. We need to know what an atom is and what an element is. Okay. Hopefully, we know that an atom is the smallest building block. Okay, the smallest particle of matter that can exist. But an element is the definition that we need to be able to remember word for word, and an element is I won't write on the orange, sorry, a substance that is made from one type of atom only. Okay, it's made from one type of atom only. Now, pause the video and read the lesson objectives. And then we need to go on to the difference between elements, mixtures, and compounds, because that's today's lesson. Now, if you look at the diagrams, what's the difference between the two? Hopefully, you can see that in the left diagram, the space between all of these atoms. Each one of these circles represents an atom. The colour means that it's a different type of atom. So here we've got a mixture because there is spaces between. Okay, you've got two different types of atom, but they are mixed together because they are not joined together. Compound, you can see here, we've still got those two different atom types, but this time they are stuck together. Now, in a particle diagram, if the particles or the atoms touch, then they must be bonded. Okay, so this is a compound because you've got two different types of atom bonded together. Now, how do we tell the difference? A mixture you can separate, a compound you cannot. The only way you can get a specific atom out of a compound is by using a specific reaction. With a mixture, we can use certain separation techniques. So, a mixture contains different elements or compounds. Okay, it could be elements or compounds, or elements and compounds that are not chemically joined. But a compound contains two or more different elements that are chemically joined. So before you go on your periodic table, I'd like you to find where sulfur and iron is. Once you've done that, unpause the video. So, which of these are compounds? So pause it, have a little think. And let's have a look. So I'm going to write E for element and C for compound. So sulfur, hopefully we know this is an element. If you're not sure, you can go onto your periodic table. If you find it there, it's an element. But the easy way to spot if something is a compound, like magnesium oxide is a compound. Sodium chloride is a compound. Oxygen is an element. Water, this is actually H2O, or dihydrogen monoxide, and this is a compound. Iron sulfide is a compound, and iodine is an element. Okay, now let's have a look at the chemical formula and what does it actually mean. So here, what I want you to do, look at your periodic table, find the capital H and find the capital O. Hopefully you will find the capital H floating in the middle at the top of your periodic table, and that's hydrogen, and the capital O is to the right near the top. Okay, and that is oxygen. once you've found them, okay, you'll understand that when we draw, instead of writing water, 2 hydrogens, 1 oxygen, okay, we write it like this because it's a lot quicker and a lot easier. So here we've got H2O. Now, this little 2 here, this little subscript 2, that means there are 2 atoms of hydrogen, and the 2 always comes after the element it's representing. Okay, so there are 2 atoms of hydrogen, but because there is not a little number next to the oxygen here, that means we only have 1 atom of oxygen. So because in science we like to be efficient, or lazy, and we like to reduce clutter, we don't write down 1s because it's implied, okay? If there is an O there, we know there must be at least 1 oxygen. It's the same in maths. If you've got 5x, you've got 5 x's, but you wouldn't have 1 times x, you would just write x by itself. Now, for this next one, I want you to find the different elements that are inside this compound and how many of each atom are there. So how many hydrogen atoms are there and how many of the other atoms are there. So pause it, have a little go. Hopefully we would have realized, just like in water, there are 2 atoms of hydrogen in this. Okay, this is sulfuric acid. Now, hopefully you know, because there isn't a little number after the sulfur, the capital S, there is only 1 atom of sulfur in this compound. And hopefully you got that there are 4 atoms of oxygen in this compound. So now we're going to do our own. So you're going to practice. How many atoms of what are here? Okay, hopefully you know that this is, and I'll give you a way to write this down for the next few. You've got 2 atoms of oxygen. Okay, 2 times oxygen or 2 times O will work. How many atoms are in this? Okay, hopefully you paused it, you did it, and now you're going to get the answer. So you should know that there are 2 atoms of hydrogen. Okay, and because there isn't a number there, that's a 1, isn't it? So we've got 1 atom of oxygen. Right, and the next one. Okay, hopefully you found that there is 1 atom of copper. So this is copper, Cu. Hopefully you found there was 1 atom of sulfur. And hopefully you found there was 4 atoms of oxygen. Again, this example. So, hopefully you found that there were 2 atoms of hydrogen, 1 atom of sulfur, and 4 atoms of oxygen. Okay, see, because there's a little 4 after the oxygen, there's a little 2 after the hydrogen, and there isn't a number after the sulfur, so that means there's only 1 of them. Now, we will do the demonstration at some point after we go back to school. We can't do it now, unfortunately. So, the demonstration that you would see is essentially you get some iron and you get some sulfur and burn them. Okay, well, sorry, I should say you heat them up. You don't burn them because there's no reaction oxygen. You react them together. So you heat them up, okay, it gets very hot, it starts to glow, and then you end up with a compound called iron sulfide. Now, iron is a silvery color, right? Silvery. Sulfur is bright yellow. Iron is magnetic. Sulfur is not magnetic. Iron sulfide is a black color, and it is not magnetic. Okay? So you've got an experiment where you've got 2 elements. This iron has certain properties. This sulfur has certain properties. Okay, so a property is its color. Okay, if it's magnetic or not. But iron sulfur has different properties to both of them. Okay, so even though it's got iron and sulfur reacted together in it, it will have a set of brand new properties that are completely different. Now, in this case, iron sulfide and sulfur are both not magnetic, but you've only got an option of is it magnetic or not, so it has to be the same as one of them. Now, here we've got a model of iron sulfide. This is a visualization. If you could see the atoms, this is what you've got. I want you to pause it and think about what does each part of this drawing represent. Okay, so you should have thought about that, and hopefully you got 3 different parts of this drawing. And it doesn't matter if you got the sulfur and the iron the wrong way around. You should have got that the different coloured atoms represent the different elements. Okay, so here's an iron atom, and here is a sulfur atom. But these little green blocks in between, these represent the bonds that hold this compound together. Now, we're going to do a worksheet next. Okay. So, let's grab that. And the worksheet is here. Now, you might have seen this before, but I think it's really, really important. We need to understand the difference between elements, compounds, and mixtures. You do not need to colour anything in. So for 1 and 2, you don't have to colour anything in. I would just read through, and when you get to 3 is when the questions start happening. Okay. So for example, if you wanted to, you could colour hydrogen atoms and oxygen atoms in. So maybe do oxygen as red and hydrogen as black. And then when you go onto here, you'll colour the oxygen red and the hydrogen black, and then you'll see that there are different atoms in this molecule of water. So that is 1 molecule of water there. That is 1 molecule. 1 molecule of water is made up of 3 atoms. So then you'll get the idea that this is a compound. And you'll get the idea that it's got 2 different elements in there. So I've got that worksheet. And that's one of the things I'd like you to email me. Okay. Once you've done that, unpause the video and let's carry on. Now, we could separate the mixture because, and we couldn't separate the compound because. I want you to have a think about those statements. So for pause, see if you can answer them. So let's unpause, and we could separate the mixture because the things that are in the mixture, in this case it would have been iron and sulfur, they weren't bonded together because they had different properties. Now, if you had a mixture of iron and sulfur, like a pile of it in front of you, you would just get a magnet and you would be able to get all of the iron out of the sulfur. So you use the fact that 1, they're not bonded together, and 2, they've got different properties. So that is how you could separate them. Now, we couldn't separate the compound from each other because they are chemically bonded. And again, what happened to the properties and appearance? Well, they all changed. So, this is kind of an application of everything that we're doing, and we'll do this again in the lesson with the experiment in front of us, so it'll be a bit more interesting. So if you look here, iron, you've got the appearance of iron is grey, sulfur, and you can see how it changes depending on the element itself, which is this is an element, this is an element, the mixture of both of them, and the compound. So you can see the difference in the properties, the appearance, and the particle diagrams. Now, last thing I want you to do, element, compound, or mixture. So pause it, have a go through, and write down E for element, C for compound, or M for mixture. Okay, so let's unpause. Hopefully, we got this. Element, element. Salt is a compound. Carbon dioxide is a compound. This is a mixture. Air is a mixture. This is an element. Notice all the atoms are the same type. So there, again, contains one type of atom. That's an element. This is a compound. This has two different atoms in, but these two are identical to the first one, so it must be a pure compound. Here, two or more elements chemically combined. That is a compound. Components not combined. That is a mixture. Here, we've got a mixture. We've got lots of different... So look, this and this are the same. They are both the same compound, but this is different than the other two. They are not joined together. They are mixed together. Magnesium, that's an element, has a symbol. If it has its own symbol, it has to be an element. Like magnesium, its symbol is Mg. Copper sulfate, that is a compound. Has a formula. If it has a formula, it must be a compound. Just like that is a formula for copper sulfate. Here, this is a mixture. Notice the magnet is picking up these, but leaving some behind. So this has to be mixed together. Iron and sulfur in a test tube is a mixture. This is an element. This is a compound. I don't know why I started writing an E. That's a compound. You see, you've got two different types of atom, but they're all joined together. Again, here's a compound. Magnesium chloride is a compound. That's the giveaway. This is a mixture of sweets. Can be easily separated. Again, mixture. Cannot be broken down. That is an element. Okay. Iron is an element. This is an element. Same type of atom, even though they're all spaced out. Water is a compound. Seawater is a mixture. It's got water in, it's got salt dissolved in, it's got other minerals in, it's got bacteria in. Oil and water, that is a mixture. Right. So once you've done that, that's the end of the lesson. It was quite a quick one, but it's very important that we recap all of this stuff from before we move on to the more difficult stuff. So I will see you next time.